Thank you. And what I'll just want to highlight is, we'll get the screen share working. Great. So we've been working with Screening Eagle, or ProSec as well, as the hardware branch of Screening Eagle for many, many years now. And we're very, very excited to be taking on a new piece of software from them, which is Screening Eagle Inspect, which is inspection management software. This is a tool that we can use to combine the visual inspection and note-taking we do as part of a structural or building survey with the scans and NDT inspection work we're already familiar with doing on the rest of the product ranges. We're really excited to have controls. I'm not going to talk about it much today at all, though it might be mentioned a little bit at the second half of the webinar. But we are able to help you see a demonstration of this tool, to set up a trial and try it out on your next project. And we'd be very happy to be your local contact in Australia for this software. So, as I said, I'll begin quickly on our main topic, utility mapping and visualization with GPR. We're just going to take a few moments to go through a little bit of theory, very small amounts. Then we're going to jump into a few case studies from Stu over in Victoria about some buried service mapping and some of the 3D work he's been doing with the GP8100 radar. And then over to Alex and Maria from Screening Eagle to give us some tips about using Screening Eagle's workspace web portal. So all the data you collect with a live ProSec or Screening Eagle system is matched in a cloud service. So you have full access to your reports and documentation in there. So a few hints about how to get the best out of that and really speed along your inspection work. And then about the GPR app and service ecosystem that Screening Eagle have created. So that'll be something to look forward to after a few quick case studies. Now, I'm with PCTE, or Papworth Construction Testing Equipment. We've been in business since 2004. Ruben is one of our founders and the current managing director. So we're expert suppliers of NDT and testing equipment, construction industry, and also the laboratory industry. So all of us have a background in engineering or in technology, and our range is broader and broader. And Screening Eagle is such an important part of this range. So that's our background. Now, Screening Eagle is the result of a merger between Dream Lab in Singapore and ProSec in Switzerland. And it's all about intelligent inspection for the built environment and the extension of asset life. So that's the background of the two companies who we're talking to you today. So ground penetrating radar. I spent a lot of time talking about GPR. And if you've got a basic background in what kind of energy it sends and the basic format of raw data, you're on a good start to at least following along while we talk about the interpretation of the data. So the most common data you will see presented is a B scan or line scan presentation, where essentially the antenna unit, could be a small one for concrete scanning or a larger one for utilities, is rolled along the surface straight, and we get essentially what's a slice through the structure. But radar technology is not a photographic technology. We're not getting a one-to-one representation of the internal structure. Instead, we're getting reflections of the radar energy coming back to our antenna. So you'll see a very characteristic hyperbolic shape shown on the right of the diagram here. And that's sort of what we use to interpret a point location. We can also get flat reflections when we're doing things like tracking the thickness of a concrete slab or traveling over a pipe or service parallel to the direction of travel. So to show you what I mean by that, let's consider that we've just got a GS8000 radar rolling along the surface just straight onto Earth. And there's no service, there's no buried utilities, but there is a change in soil layer some distance down. If we look at the outcome in the raw data, the unmigrated data, we're just going to see a strong reflection at the surface, because the first reflection is always from where the radar energy enters the ground or enters the concrete. And then the second reflection is going to be that layer change. So we can see here that tracks the position. So the closest point is always the closest to the antenna. So we just have a flat line showing its depth. Now, if we go and instead look at a embedded object, so this might be a reinforcing bar embedded in a concrete structure, or it may be a steel pipe, we've crossed at 90 degrees with a utility radar. This is where we see our characteristic hyperbolic reflection. And that's because we get signal from that target before we reach it, when we're on top of it, and when we go past it. So the closest point is sometimes behind or in front of the antenna, which means we get a characteristic hyperbolic reflection with the target we care about located at its peak. I've also shown on this diagram, just because I use it for training purposes, some of the other characteristics of radar scans. We've got a little bit of shadowing underneath that metallic reflection. That doesn't always happen with non-metallics. And we've also got several stripes showing the positive and negative polarity of the radar energy. But that's not very important for what we're going to discuss today. So just 5 seconds of theory. I'm going to hand over to Stuart now and let him go through his case study he's prepared. And if there's any questions along the way, please let us know. I'll be keeping an eye on the chat and offering as much support as I can. Thank you.
All right. Yeah, thanks, Will. And hey, everyone, thanks for joining us today. Look, very excited about all the ProSec GPR equipment and just the huge kind of like updates and improvements that we've seen over the last few years with all the GPR reporting like side of it in particular. As you saw from Will's slides there, the theory of GPR, you have, you know, what we call as line scans, where we're needing to be interpreting what we've seen. And really, I think, just to talk bigger picture, you know, the amazing development from ProSec has really been on the reporting side to give kind of our customers and your customers a report that they can understand, where it has, you know, rather than hyperbolas and grayscale, you can actually just get an image of everything that's in the ground, everywhere that you've traveled with either a utility GPR or a concrete GPR. And that's really what I'm going to talk about quite a bit today. I'm just going to start with the first slide just to lay some of the groundwork and concepts that kind of lead into that, to kind of show you where we're starting and where we're headed. And then at the end, ProSec is going to take over for the second half to show you a really exciting update that's coming out for the GS8000 utility GPR. Yeah, so if you could you just go to the next slide if you could, Will. So. All right, so utility locating technologies, an EM probe, which is a wand, is a common technology that's been used for many years. Sometimes as well, you need to do more invasive, you know, putting things into the ground to feed it through to see where the utility was leading. And then GPR being a very advanced technology that can find metallic and non-metallic objects. Of course, the operator is needing to interpret with any of these technologies to tell you what's there. And if you could just go to the next slide. I'm just going to talk a second as well, which is another key piece of this puzzle, is GPS technology and the integration of GPS with GPR. So just to talk generally about GPS with your mobile phone, you know, it's not very accurate as you drive. It becomes more accurate if you have as you're moving. And then you have kind of WAAS, WAS, you know, GPS, where you're looking to how many satellites you can see in the sky, and you get pretty good accuracy if the GPS device you're using can see quite a few satellites. And then the most accurate here for Australia would be like an RTK corrected GPS service, and that's going to give you centimeter accuracy, which is really where we start to see the benefits of integrating GPR technology with GPS. Go ahead. All right, so this is a GPR scan on the left. Makes complete sense if you're a GPR operator. If you were to give it to someone who's never seen GPR before, it's difficult maybe to understand. But what you deliver to the customer is markings that you put on the ground that they use to decide where they're drilling or cutting or excavating. And, you know, you take some photos of where those were, but often we'll see that in, you know, a little while later, those marks would disappear. Somebody have to come back to scan it again. And, you know, that's probably quite a bit of the, you know, like deliverable at the moment that that we see for for GPR work and utility locating. Just go to the next one. So currently with the GS8000, we have a GPS that's included with it and integrated into the GPR. So as we're collecting data and we're marking targets, the depth of each target and the GPS coordinates are recorded. And then we can send that information to customer in several different formats. They can open in survey management software or in Google Earth, which is what we've done here on the image on the right. So I think this was some scanning work that Ruben actually did in Perth, but we marked several utilities, like a few different times to see the path of them. And this information can be provided to the customer to get GPS coordinates which are accurate with an RTK correction, and the depth of each target can be provided. So this can already be done with the GS8000, and it's a great output of the device. Go to the next one. So here's another one that was done recently in Melbourne. We're just looking for a power conduit that was running from a parking lot to commercial buildings that were being put in. So I've just marked it several times in red. You can see as well in this scan that with the GS8000 at the top, you can see each individual bar quite clearly. It's a stepped frequency GPR, so we get very good clarity of all of our top layer of reinforcement, and we can also see deeper targets. And here's one that we've opened up in Google Earth. We've recorded a depth at 0.5 meter, and this is something that we can just provide to any customer to put into their survey management software. So just go to the next one if you could. All right, so I don't want to spend too much time here because this is a large part of the presentation later, but currently, if we were to prepare imagery like this for a customer, we would need to put together what's called an area scan. So we'd need to be marking out a large grid, maybe 5 by 5 or 10 by 10 meter. And we'd have to be collecting all the lines in that grid. But with the benefit of a very accurate GPS built into the GPR system, it can actually record the path of the GPR and where it goes. And we can produce this type of imagery with the new update without needing to mark out a grid and quite seamlessly. So where we're moving to is being able to give customers an image like this of all the services through an intersection rather than a grayscale or markings on the ground. And it's a much more powerful thing for that asset owner to have because it's a recording of everything that's present in the intersection, and it's completely tagged to the GPS coordinates and depth for each of the utilities that's running there. So just go to the, so that's been a big progression, and it's really what the market's been looking to have, is that GPS integration with GPR. And we're just very excited that we'll hear more about it from ProSec later in this call, but we're just very excited that it's being moved that way and that it's becoming a reality. Next, I'm just going to talk a little bit about the GP8100, which is a concrete scanner. It can go to 700 mil depth, and it has 6 antennas inside, so it's an array. Each time that you move it forward, you collect 6 lines of data. And you can collect really big 3D models using this GPR up to 180 square meter and flexible grid size as well. So I've done a number of different kind of large grids with customers that they canvases they put down, or they can just mark out grids on site. But you can do 2 by 2 meter or 1 meter by 9 meter long like 3D models right on top of the concrete that you're scanning. But just go to the next slide if you could, Will. So this is a multi-level parking. This is a multi-level parking garage in Melbourne. So if we're just looking in here, this is kind of more of a traditional GPR view. So again, we've got that grayscale, which GPR operator can interpret quite well. Each of those hyperbolae are there's their targets inside the concrete, and then below is the bottom of kind of the slab. And then we've got like a heat map view below that, where it kind of takes that and simplifies those curves into red dots, which are the targets. Now with the GP8100, we've got something called a superline view, which is on the right-hand side. So as you're moving the antenna over like any steel that's inside of the concrete, you can actually see just the red lines, which are the actual like steel bars that you're traveling over. And you can see as well, there's some that are vertical there, but we've also got some that are on a slight angle. And those were actually conduits that were running inside of the concrete. And because each time we move this array along, we actually have 6 antennas inside. We can see things that are on an angle like that. And this view is basically all 6 of those scans put into one and giving us a much more visual view for the area that we scanned. And we can clearly see all the bars and any conduit, even if it's on at an angle within the concrete. We'll just go to the next one here, Will. All right, just stop there. Okay, so this was like a 3x4 meter area scan that we did in the same, basically on the top. And collected it in about 5 minutes time as a 3x4 meter grid. And when we were finished, we were basically able to have a complete model which shows us all of the reinforcement and all of the power conduits that were inside of this concrete slab. So not only can we be confident about, you know, where we're cutting into the slab, but for structural drawings or providing the asset owner with something, we could just give them like a 3D model of everything that's inside of the concrete. If you could just see on that 3D scan as well, there's a purple kind of rectangular object there. So that was actually in the bottom left-hand corner. There's a photo there where we're looking kind of from the level down below. So there was an LED light that was underneath the slab. So that's actually what that purple rectangle is. And then there's a conduit that was running to provide power to that. Yeah, and then so there's that, that's actually the LED light. And then there's actually a conduit that was running like at an angle, and you can actually see it going across the span of the concrete there. And look, that was always difficult to see with GPR before, because on some line scans, you'd see it clearly, and on others, it would be at an angle and it was hard to see. But now what we can do is just a full 3D model. And you can imagine giving the customer something like this when you're done is much easier to explain than kind of the grayscale image that you used to get and markings on the ground. And also, if you were to go back to this site, you can bring this 3D model up instantly. You don't need to scan the whole thing again. As long as you know where the 0, point of it is, you can bring up the whole grid straight away again for them to see what was inside the concrete. Okay, we'll go to the next one. So here's just another example. That's the GPR there. So it's got a telescopic rod with the iPad mounted on top, and the probe's about 300 mil, but it's really good for scanning large areas. This again is about a 4x4 meter area we've scanned, and we found a number of conduits that were running in the floor, and they were all headed to a junction box. You can kind of see, well, kind of top left corner there of the model, and you can see it both. That's the plan view looking down, and also in 3D on the right-hand side. And again, it was about a 5-minute data collection here, because yeah, it's not so many scan. Each time that you move the GPR, you basically do 6 lines at a time, so it doesn't take too long to do this type of a 3D model. Yeah, and I think very powerful. So that was pretty much it for the 2 presentations I had, and I'll just pass it over to Prosek.
Thank you, Stu. No problem. So Alex, thank you very much for joining. You're free to share your screen now. That should be available.
Okay. Let me
Actually, one
show
quick
you my.
point before we start. Peter Matrevsky asked, what is the difference between a gray and light blue in previous slide? So I think that was the one that was referring to the scan of the parking structure. Looks like.
Right. Yeah. I think the gray was a Bondex section, and the dark blue, I think, was the light that was the LED light that was below. It was just that, like, basically with the 3D, the way it works is that you kind of have different colors for each layer. So I think the light blue section was a Bondex section, I believe, just from memory.
No problem. And sorry, thank you, Alex. I apologize to.
No problem. Well, first of all, thank you guys for joining today and also giving me the chance to do this presentation. Yeah, I put some things together. Hopefully, it's a meaningful presentation for this event. I'll talk just briefly about how we are changing data collection. As Stuart already mentioned some of the points. Then more on the data processing, what we are doing there, and just giving a sneak peek on the GS 2.0 that Stuart was mentioning also, and the new software Screening Eagle GPR Insights, and how this just make our Screening Eagle Technologies ecosystem more powerful. So yeah, Alex Novo, I'm head of product management for GPR applications for Screening Eagle Technologies, and sitting at the office we have in Malaga, Spain. I'm originally from Spain, although I lived most of my life, my last decade at least, out of Spain, spending time in different countries, Italy, Canada, and US, always linked to GPR technology since 2005. And just joined Screening Eagle back in January. Very excited about this new career path and the things we are doing. And in Spain, in Malaga, we have a R&D center for artificial intelligence and software. So I'm very much involved in all GPR products, but more precisely on the software part that I'm gonna just present a little bit on the data processing side. So before processing data, of course, you have to collect the data. So traditionally, you collect the data probably setting up a grid or just doing random line scans, and then acquiring data over a grid involves kind of being a little bit precise, trying to walk these straight lines, so it's prone to human error. And then you usually place some marks on the floor, as Stuart showed. That's the traditional method. Then you can collect those marks with photographs or asking some surveyors to go there and GPS it for you. And then there is last part of the project where you try to merge all data, make sense of all of it, and report. So we are trying to improve this workflow, and we spend a lot of time thinking how to make workflows more efficient and just better for the client, for our users, from the data acquisition to the reporting, the whole thing. So we are trying to walk away or give more freedom. I don't know if you can walk away from grids at all times, of course. You have some constraints sometimes, but with the GP8100, we introduced the Superline. So as Stuart mentioned, it's a 6-channel array. So even though if you want to collect an area, you're going to do a grid, but still in one pass, now you have way more information than just one V-scan. Then with the GS 2.0, the next release with the free path, you can create that, like you see here on the third image on the right, So you can see tomography or CT scan, building in real time, georeference. So you have 2D and 3D data in real time that provides accurate mapping. And then we are working a lot on also huge amount of options for exports and reporting. And one of the, here I put an example of Inspect that we'll mention in the beginning. So from field to client, trying to improve these workflows. In terms of data processing, well, you already saw, and many of you already know, visualization in our ecosystem is quite powerful, from raw data or unmigrated data to migrated data, then these tomographic views in the form of CT scans or isosurfaces, and then we also have augmented reality. So why more processing? You could think, right? Well, sometimes you need to do more just because maybe the structure that you are scanning, and this is a beautiful example from Guido Tronca that many of you maybe know or heard of, and this is all the GPR data he collected over this arch, put it in the right geometry. So here, for instance, geometry is key for data analysis of this structure. You can do this with advanced software for data analysis. Sometimes because of GPR limitations, in some areas you have more attenuation, you have to try to increase contrast, and then interpretation might be tricky. So you will need to treat your data in a different way. So a standard, as I show, just with unmigrated, migrated, and those quick tomographic views might not be enough. And sometimes you just need more context to do interpretation. This is an example of bringing not only satellite imagery, but also an as-built, the XF, for instance, of the utilities that at least there are records of it, and then you can overlay your GPR data on top. And then you can create this at a big scale, and this gives you more context for proper data interpretation. And then this is key. So sometimes you have good raw data, like in this example, and this with the GS8000 and the GP8100, or at least with most of the data I've seen from PROSEC GPRs, is usually quite clean. SFCW GPR is quite a powerful GPR technology, but not all the time. As I said, there are many limitations, and you have to do many times this sort of standard processing flow on a third-party software, trying to increase the targets you want to visualize and how they look like. This standard processing flow that I'm showing here, that accounts for traditional filters like time zero, gain, bandpass, background removal, migration, Hilbert transform, they're all pretty much built in on the app. So it's quite easy to get there with not much effort and start tagging your data. Like here, there are several hyperbolas. You can also, and we always recommend this to our clients, to have a look also at the A-scan. You have just swipe from left to right on the app, on the iPad, and then you can place your tags here, finding the maximum on the Hilbert transform on the envelope, which is this red line here on the A-scan on the left. And then you just place this, and usually you would have this on your data quite easily to do, but not always. And I'll show some examples. I mean, when you can do that, and with some experience, you can have this sort of advanced data interpretation, like in this beautiful example. And as I said, we get to all these steps that usually post-processing requires several steps with just one swipe of the fingers from top to bottom on the app. And you get this beautiful migration plus Hilbert transform B scan, and then you can just see also at the A scan, as I said. But sometimes, yeah, you have to play with the gains because it's not enough what you see on the raw data. So you have this linear gain, time gain. This can be critical. Sometimes you have noise coming from external sources, and you have to apply some frequency filter, some bandpass filter. Here's an example how to remove this noise on the bottom floor, and this is on this frequency filter. We just bandpass it on the low bandpass here, and it improves the visualization on the bottom of this B-scan. Sometimes you have background noise, like this horizontal banding, and you just you can apply the background in different time windows on our app to remove those band noises. You have to be careful with those. If you are looking for utilities that might be running parallelly to the surface, you should be careful not to remove those reflectors that might be true targets. And then also you might have Airwaves. So with this dielectric constant functionality on the app, I encourage everyone to always use it, to have true or close to the most accurate depth estimation, but also sometimes to find that this is an airwave because it's the electric constant of 1. Sometimes, though, you need to walk out of the app and do some advanced data analysis. These are examples in GPR Slice. As you know, we have good partnership with GPR Slice software, and this is an example on 3D horizon mapping for geological mapping. It's an example of one of our clients in Spain, in a beautiful limestone environment. So the depth was, as you can see here, around 8 meters. If you want to do tunneling and as I mentioned on the bridge example, account for the true geometry, then you might need to do this also on external software for advanced analysis. Or this is another example, believe it or not. I'm not putting here a lot on utilities, but just to widening the range of applications. Archaeology sometimes is very challenging environment, so it brings a lot of new ideas to data analysis for GPR that then can be applied to utilities or concrete, of course. And many of the breakthroughs in GPR software processing came from archaeological mapping, believe it or not, in the past. This is an example of a Roman mosaic that we had to find these air gaps created by microorganisms that were destroying the tiles. And sometimes what you see here, this is real GPR data with different isosurfaces, thresholds, and overlay analysis, quite complex analysis of data, and this requires extra piece of software. And this is the isosurfaces with the digital terrain model extracted from the orthophotos. So this usually requires a lot of steps. And this what I'm showing here is just the standard post-processing workflow from raw data to 3D, not even going to what I show here. And this requires like around 50 steps. So my analogy would be like doing a solo climbing. Here, I mean, you feel great if you get up there doing all this, but I mean, you can miss a step at any time, and you're on your own here. So we are trying to help this for new users to get to advanced data analysis without going through all this ordeal. And I'll give you just a brief sneak peek on how we are doing that. The first one is by unlocking your path. We title it like this to the event. I don't know if you guys had the chance to watch it, but it's on our website. You can go and watch it again. So with the GS 2.0, you can do this kind of mapping. So this is in, well, it's a little bit fast forwarding, but you can see that this icon is representing the GPR in the field and is collecting back and forth without any grid in the field, just relying on GNSS accuracy. And you can see the B-scans traditional view on grayscale here and the tomographic view on the right-hand side and how it's tagging. And then, after you tag and sketch, then you export. And for many of your projects, that would be enough, as I mentioned. But for those that are not enough, then you would need a post-processing or data analysis software. And we are jumping from all those 50 steps. We are merging those 50 steps in 3 steps. We're importing the measurement, creating the project, and then you go right into 3D visualization. We want to keep a visualization at core, and we make those 50 steps for you, let's say, that then you can modify. So it's still flexible software, but at least you can get to this 3D data visualization in these few clicks. How this fits in our ecosystem? Well, we have Inspect that can be also used for the job preparation, collecting data of photographs or geographical data, any notes or sketches. Then you can do the field data acquisition with our sensors, as you saw, GS, GP, and then you can do reports and more drawings with Inspect, but we were missing this piece that is bringing GPR Insights, that is this advanced data analysis. Everything is now linked together through Workspace. As you can see here, is from field to client, everything is in your Workspace. So Workspace is our cloud-based platform. You finish collecting data, this data is being uploaded to the cloud. You can access not only on your iPad and your app, but you can access from any computer, just accessing to your Workspace. And from there, you can access GPR Insights. Because GPR Insights is a web-based software, you can access from any computer, any browser, any operating system. And yeah, GSGP is a subscription-based Workspace is included, so it's free. And GPR Insights could be optional in Workspace and at an extra cost. And I think it's a great data analysis solution, GPR Insights for all GS8000 and GP users, maybe GP8100 more as they collect data in 3D. And yeah, as a final slide, I invite you all to our webinars. We have 2 today, maybe too late, but then we have 2 next week where we will be unveiling the GS 2.0 and GPR Insights more. This was just a brief introduction to what they are about, but we will go more in detail on these webinars. So yeah, I conclude my presentation here with this slide and inviting you. So thank you.
No, thank you very much, Alex. It's greatly appreciated. There's some good examples there. Just a couple of questions I've been answering in the chat, mainly about the different kinds of target and distinguishing them. So certainly, depending upon where targets are, you can distinguish between metallic and non-metallic targets on radar data. But between metallic targets of similar size at similar depth, they're going to have very, very similar reflections. It's going to be very hard to distinguish between those. Maximum depth of the GS8000, it's really controlled by the soil. If you've got a very conductive soil, it's going to be very low penetration, whereas a very dry, very non-conductive soil, you'll have a much deeper penetration. Loose guidelines could be as little as 1 meter to tens of meters in ridiculously good environments, which we don't see very often, of course. Does anyone else have any other questions before we finish up for the afternoon?
I would just say with the GS8000 for the top meter, it's it's just so much better than any other utility GPR I'd seen before. So like it just picking up small targets, particularly in the top meter.
Yeah, it
And
seems to
then
make wonderful use of
yeah.
the high frequency energy content of the signal.
Yeah, like when you zoom in, I mean, it's very, very good data, even compared to concrete scanners in the top meter. And then I would say, like for the maximum depth, because in Melbourne we have a lot of clay, so it really limits like the depth of any GPR for how deep you can see, and it's as good, you know, as any other GPR I've seen for utility locating. Like for the deeper targets. So huge improvements in that top meter, and then like similar limitations just because clay has so much water inside, and it just limits the GPR depth of even any frequency of GPR, because you can't just go with like a lower frequency and expect to see twice as deep or something. It doesn't work that way. With clay, when it absorbs a signal, it just around that maybe 2 to 2.5 meter mark in Melbourne, in particular in clay soils, it just doesn't go much deeper than that. But in sandy soils, you could see even down to 8 or 10 meters, as you showed, Alex, in some of your slides there. So yeah, that's all I would add.
Yeah, that's wonderful, Stu. And look, thank you everyone for attending. If you've got any more questions, drop them in the chat. You're welcome to unmute and say hello. I guess I can finish up our recording session now.